Going to take a look at some supplies we got. And today, got a few little things to take a look at. I have a generic PIC microchip programmer with cable. So let's take a look at that and see what we got here. It's some soldering wick, USB cable, and I'm gonna go get a pair of scissors and I'll be right back. Run up the anti-static bag. And we have a PIC microcontroller programmer. Looks like they sent us some screws to make standoffs on. PIC programmer cable, ribbon cable. Single-sided plug-in. Right there. And a zero insertion force socket. Well, that starts us off. Besides that, we have a soldering wick. Doesn't look like it's any name brand, but you can never get too much solder wick, removing components and whatnot. Looks like it's a fair size. You can add a circuit. Cover one whole circuit pad. So here's an example of what you get with the PIC kit programming board. I have not yet tried this out. I have some PIC chips on the way. Matter of fact, they may be in another bag already, so we may have to do a video on this later to see how this works and get an evaluation on it. But as you can see, that's what it makes up. This all comes in one bag, and I'm not exactly sure why, but they sent me a desoldering wick there also on the side, so I don't know if that's a good sign or a bad sign, but anyhow, this bag's from a local distributor, and it has all kinds of goodies in it. So we have some transistors, large format. They're the 3055s. I believe that's NPN, but I might be wrong on that. Got a whole bunch of chips. Let's take all these out, line them up here. That looks like them. Yeah, that's some PIC controllers that I was referring to earlier. Did get them in already. Let's take a look at the IC chips right now, and get an idea of what we got here in this shipment. Okay, so to start things off, we have this one, which is a PIC 16F microcontroller. We got 3 of them. This ought to work fine with our new board, so that's what we'll be trying out with that. Next we have a LM339N, and I believe that is a comparator. So we have a comparator here, a couple other comparators, op amps. This is another op amp. Let's see here. This one is a low noise op amp. This is a high precision dual op amp. This one, and I believe it's this one, is standard 555 timers. This is a single timer, and this has a dual package timer. There's 2 555 timers in that. This one, I believe, is a Thompson timer. It's slightly different, but it's still a 555 timer. So these are 555 timers. The last one we have here This is a photo transistor, or a opto isolator, optocoupler maybe, you might call it that. So this is our line of microchips, and I'll be putting each one away in its own area or department in my box. Start off with our PIC chips, put them away. We're going to keep all of our microprocessors in one separate drawer. I always leave the tags with everything so I know where I got it, the part number that I got it from, and exactly what it is in case I need to reorder. All these are also going into a database, so anytime I use one, I log one out of the database and I keep an inventory. I have running inventory of what's in there, along with the schematics and everything linked together. Okay, so these would be my comparators. I'm putting everything in a bin, and they go into my supply drawers up here. Now let's see, we got this one here, which is op amps. So 555, 555, 555 package timers. They can all go together. That'd be precision op amp. So all these ones go together in a bin. These ones go together in a bin. Okay. Now we have a nice large selection of passives. Got a little bit of everything in here. So we're going to look at these and try to sort through them. Alright, these little guys right here are resistors. They have two leads, one on each end, a color code, which allows you to tell what they exactly are, what value they are. And they always stay the same, so the value never changes. That's why all these components are referred to as passives. A transistor, for instance, it changes depending on the input that you put into it. And these don't change. They stay the same all the time. They're constants. So let's start sorting through these. And how I'm going to do them is like this. If you look at this one here, and let's try 100K. All right. $100K and 1K. If you look at the color coding on it, now you see this one is a 1 kilo ohm resistor. This one is a 100 kilo ohm resistor. If you match up the browns, which would be this end here, you can actually figure out which one's which by the color code. So, being this is 100 and this is a 1, I'm going to put these in the same container. I'm also looking for, if I have, here it is, a 10 ohm resistor. I'll add it to the same container because they're all 1, 0, so all these are going to go into the same bin. So if I'm looking for 1 mega ohm, or anything, here's 100 ohm, all these will be in the same bin, so it'll be easier to sort and I won't have to have an individual bin for every single one. This is a 10 ohm, again 1, 0 is what I'm looking for. There's another 10K ohm, 10,000 ohms. And I think that should be all of the 1-0s. If I find something later on, I'll add to it. But all these are fixing to go into their own bin. I got one rack that's for nothing but resistors, so all my resistors will be going in one row. My optocouplers, isolators, comparators, and op amps will be going in the second row. Now this is where it gets a little bit odd because some of these are odd valued, so we're going to have to go through them one at a time and see what we can link together and what we can't. Let's see here. Okay, since I don't have enough, for instance, 1.5 ohm, and the next one would be 15 ohm, then the next would be 150 ohms. Since I don't have multiples of the first two digits, which is 1, 5, I'm going to clump these together. So I got a 1.5 ohm, a 3.3 ohm, a 3.9 ohm, 2.2 ohm, 5.1 ohm, 2.7 ohm. Take that 5 out. I won't put that in there. And a 4.7 ohm. So this will be 1 to 5 ohm drawer. So all these will be 1 to 5 ohm resistors. Now we're going to have 5, 9, 8, and 6. So this will be a 5 to 10. That can go in there too. Yeah, 5 to 10 ohm resistor table. And all of our resistor passives have been taken care of. And looking back at what we have here, this is a diode package. This is a capacitor. Like the resistor, the diode has 2 leads, here and here, and the capacitor has 2 leads, here and here. However, the diode is marked, has a band, and this kind of capacitor, electrolytic capacitor, is marked also with a negative sign. So these ones actually have to go in certain ways. The resistors are bipolar. That means you can flip a resistor around either way and it doesn't matter which way the electrons flow through it. This one will only allow electrons to flow through a certain way, and if they try to go back the other way, it stops like a chuck valve. It stops the electrons from going the opposite direction. What this does is, this is more or less like a tiny storage compartment. Electrons can flow in and it'll fill up, almost like a little water tower. And then when you turn the water pump off, or the flow of electricity stops going to this, this will discharge its surplus into the circuit. So if you have a, let's say, a blinking light that's blinking, and you apply one of these, it'll allow the light to stay on longer, because it'll store a small amount of electricity, and then when the power goes off to the light, this will supply electricity for a small amount of time. This can get a lot larger. In fact, they made some makers are actually using capacitors, supercapacitors, not quite this size but a lot bigger, to start cars with. So I'll probably put a link to that video in the bottom also. But all my capacitors and my diodes, we'll go to the next drawer up, and that'll be both for capacitors and diodes, because I shouldn't be having too many of either one, a large quantity of either one. For those, I'll be able to once again clump them together like I did the resistors. Now we have transistors. All of these are transistors of some type. There's many different types of transistors, and technically a FET, JFET, etc. is in, even a MOSFET is in a transistor family, because it has 3 leads in the way that it's actually conducted. It has different layers of silicon and different components to allow it to change value. Now we have high power and low power systems here. These would be a high powered transistor. That is, if you look at them, they have a piece of metal on them, and you can mount this onto a piece of metal, such as like a heat sink. Let me see if I got one here. Heat sink. Yes, I have some. You can mount this on the heat sinks, and so if these start getting hot, then the heat sink will help dissipate the heat, and it will allow these to last longer lifespan. Then you have an even more powerful transistor, which once again goes to a piece of steel or another heat sink. Sometimes you'll see these in like amps, and they'll actually just be bolted straight to the steel. But this is a transistor. Each one has 2 pegs, 1, 2, to this, and then the third one is the ground. It's this shell right here. And all these transistors do basically the same thing. They're an electronic switch of sorts. That is to say, if you want to, as an example, conduct electricity from here to there, let's say it's a positive, so you want to conduct from here to there, you apply a ground, a negative there, which will sink it, and that'll turn the flow on. Or, in some, that'll turn the flow off. So it just depends on which transistor you have. But what we have here is a large selection of them. So one at a time, I'll try to go through and show which one's which. This is low power transistors. In fact, if I'm not mistaken, a 3906, I believe, is a PNP transistor. Kind of get a good look at it there. And so this is a PNP transistor. This one is an NPN. Now, how I remember it, this is PNP, positive, negative, positive. This is an NPN, negative, positive, negative. They look very similar, but the actual part numbers are different, and they work very different from one another. Now this one should be a MOSFET. It looks like an ordinary transistor of the smaller value for the most part. They're approximately the same size, they're the same package, but this works a little bit different. See if I can explain it. These ones work by the amount, the flow of electricity that you apply on it. In other words, the amperage that you put on it tells it how much to switch on or switch off. This one, on the other hand, FETs, they generally work by how much voltage you put on them. The more voltage you put on them, the more current they allow, or less current allow. Depends on which way the FET is. But this FETs are usually controlled by voltages. Transistors of the NPN, PNP value, the standardized transistors, are controlled by amperage. So if you put 12 volts at no amps on this, it isn't going to turn on the same as if you put 12 volts at no amps on this, because this one will actually kick all the way on or kick all the way off depending on which way it's set up. Okay, so we got those ones knocked out. Now let's look at these ones. 179 is actually not a, this part number, the 7805 is actually not a transistor at all, but it kind of functions like one. It's actually a voltage regulator. So what it does is if you apply 6 volts to this, no matter what, it'll keep the voltage at 5 volts. So this is whatever in, 5 volts out. This 505 falls in the exact same category. It's a voltage regulator also, but it's a 12 volt voltage regulator. This is a 5 volt voltage regulator. This is a 12 volt voltage regulator. So if you have 15 volts coming in, but you only need to have 12 volts out to run a circuit, you can apply this to it and it'll allow you to run a 12 volt item on more voltage than that supplied. This is a PNP. I think that's a PNP 2955. I believe this is a PNP transistor, and it's the same as the smaller transistors except for the fact that, once again, like I noted, it has a heat sink on it, so it can dissipate more heat, it can move more power. These ones will burn out where this one will be just fine at. And that should leave a NPN transistor set. Let me see if that's, I'm pretty sure that's what this one is. Yeah, NPN transistor, 10 amp, PNP transistor, 10 amp, and let me see, these ones down here are just general purpose, so I think they're a half an amp, but I'm not exactly certain on that. And then you got the big ones here. This is 15 amp, 60 volt, NPN amp audio transistor. I use these a lot whenever I need a lot of power to run something. And that rounds up the transistor family. Okay, so now let's go through the rest of the items in here. We won't open everything up, but we'll take a look at them as we go through them anyway. Let's see. Well, we have a couple more passives, it looks like. Nope, those are diodes. These are diodes similar to the other diodes, except these operate a little bit differently. These may be, yeah, these are switching signal diodes. The other ones were silicon diodes or power diodes. These are switching silicon diodes. They cannot handle as much power running through them at one time. However, they are quicker. When they switch on or off, they switch on or off at a lesser value. That will go in our diode drawer. Let's see what else we have in here. Okay, these are pin headers. We got 40 pins, another 40 pins. These are the SIP sockets, so that should be 2 parts. This is 1 part, this is 2 part, because this is a female or male header. And then you got the 40 pin female header. So this one and this one go together. And then you have this one, which is actually a socket. If you look at it right in there, you can see you can use them as a socket to plug things in. There we go. Plug things in, or put wires in, put IC chips. I can use them for IC chips. There's a lot of different things you can use these for. So these are all my headers. We'll put them away. Get this bag out of here. Next we have 18 pin dip sockets. This is so you don't have to solder in IC, an integrated chip that has 18 pins. You could solder this in and then plug the IC chip in and out of it as needed. So if you ever need to replace it or anything, it'll be easier. This one is 8 pin dip sockets. Same thing but for 8 pins. This one's the same thing but for 24 pins. Same thing, 16 pins. I think I got another one here. And this one is for 24 pins. So you can connect one of the op amps up to them or any of those integrated circuits. Okay, we have 2 displays, LED displays. I believe these are common green. Let's see, yeah, green displays. Here is a heat sink, larger heat sinks. This is for the 202 package, and even bigger heat sinks. So you have from the small heat sink, dissipate just a little bit of heat, medium, and large. Moving on. We have switches. This is a dip switch. Dual inline package dip switch. This is an 8-pack. So each one of these has 8 switches on it. You can use these for logic circuits or anything that you want to make flexible as far as programming goes or as far as usability goes. Sometimes you're going to have electricity run through, say, switch 1, and sometimes you want it to run through switch 3, so then you turn switch 1 off and turn switch 3 on, and so you kind of get the idea of that. Alright, now we got alligator clips. I think there's 10 of them in here. Let me see. You always need alligator clips whenever testing products. Always. You can never have enough alligator clips. And we got red, green, black, yellow, and white. 2 of each. Yep, 2 of each. So that should be 10 of them. Next we have strip board and pref board. Now what's the difference? A lot of people get this mixed up. Strip board actually has strips. So if you connect something here and solder it, technically you can actually connect something there and it'll all be connected on one circuit. You don't have to run a wire from there to there because this strip will power anything on that row. It does not work in columns, only in rows. If you need to make it stop at certain spots, you can use a drill bit and drill this side a little bit larger and it'll break that circuit. Or you could take an X-Acto knife and like a razor knife and cut a little piece of the copper out and pull it off. This is a strip board. This, on the other hand, is a pref board. Pref boards simply are holes with little dabs of copper pads on them. So if you put a component in there, say a diode, you can connect it up and solder it and it'll be right here. But if you wanted to connect to something down here or down this way, you have to run a wire or trace all the circuits together, something of that nature, in order to make them connect, because nothing's actually connected. It's just individual pads that you can solder on. Both of them have their certain place, and so I keep both of them on hand as often as possible. Next we have tape. This is a high temp tape. Take a good look at it here. It's a high temp tape. You can put this on a piece of circuit or material that you don't want to get too hot, and it'll help dissipate some of the heat. Also, it's non-conductive, so if you put it down over top of a piece of circuit and then lay another piece of circuit on top of it, then it won't conduct the energy between the two. But it's for high temp. It's, I think, rated 400 degrees. I'm not sure on that. I'll look it up. Next, you have switches. These little guys are push button switches. You might not think about it, but a lot of things like microwaves and stuff actually have small switches in them, and this is one of the sets that a lot of them use. I have it set up so it'll work inside of a breadboard, or like I was saying earlier, it'll fit perfect inside of a pref board. So that should conclude most of our miscellaneous components, and I will see you next time when I get another shipment in.